re-platform on top of Kubernetes. We're going to toss fleet entirely, and we're going to reship Deis as a set of Kubernetes services. You will be able to inject in Deis into any running Kubernetes cluster, which then provides that workflow layer. So if you want to get push, you want source to image, we can provide that on any extant Kubernetes cluster. So this is kind of what the tech stack looks like for us now, pretty much above layer 5. Kubernetes can run on Rocket. It doesn't necessarily have to run on CoreOS. It can run on any virtual infrastructure.
Is that possible? Can you make it bigger?
I'll tweet a link. Follow me on the thingy, and I'll actually do some about computers, and then I'll tweet a link to this stuff. Let's see. Any questions at this point?
No, just to give you a heads up, you're putting more in.
Okay. All right, so I will. Okay, the last point that I'll make before we get into the guts of Kubernetes is, and go back to the earlier point that Google maintains that Kubernetes is not an orchestration system. They maintain that Kubernetes is a container cluster manager, and that necessarily you must have at least 3 properties. And they define these 3 properties, and that link that's tiny up at the top is the link to the Google platform blog where they actually talk about this. So they define the 3 things. Dynamic container placement, meaning that containers can be scheduled onto any node in the system. You can hint into that scheduling, but it's not something that you should necessarily define. You can say, this thing needs SSD, but not put it on this box, because you need to not care about boxes, you need to care about attributes. Then the middle one, which is super interesting, is loose coupling via labels. So instead of dictating a hierarchy of how applications run in this container cluster, you're able to lasso various workloads, both vertically and horizontally, or however you want to think about it. So you can say, these sets of things are participating in serving my application and are part of the front-end tier or the back-end tier, which is pretty different than how you would normally say, okay, I've got a 3-tier application, there's a load balancer, there's an application tier, and there's a back-end tier. This allows, once you kind of get label selection, allows you to do things like canary deploys and rolling deploys, essentially for free. And then the last one is name resolution and service discovery. So once I deploy a service into a cluster, how the hell does it find out who its neighbors are and how does it attach those services? Microservices or whatever. There are cluster services that all facilitate running a large application workload. How do they find each other? So those 3 things are super important. I'll get to. So this picture is 3 things inside Kubernetes, and we'll just kind of end with this instead of going through a full rolling deploy. At the highest level, we have a service. It has a name, and it selects things within the cluster through label selection. And it says anything that is labeled app equals my app is under my purview, and I'm going to route traffic to it. Underneath that, a replication controller is responsible for ensuring that there are n number of things. You tell it, I want to have 2 replicas of my app, version equals 1, and app equals my app. And if 3 are started, it will kill one. If there's only 1 running, it will boot another. So these very simple primitives that you can then construct higher order workflows on top of. So in the example I talked about earlier, this allows you to inject a pod into the Kubernetes cluster with version equals canary. It's running outside of the purview of the replication controller, but within the selection criteria of the service. So the service will now transparently route traffic to your canary workflow, or to your canary deployment. That gives you a lot of flexibility because it's just composition of very straightforward aspects of the system. So on top of that, you can boot a second replication controller with a different version, and then you can just tell the Kubernetes API, which is a declarative API, make 2 of these 3 things, make none of these things, and then you're done. So that's how you facilitate rolling deploys. So again, the reason why Deis as a platform decided to jump onto Kubernetes. Vibrant community, years of experience, a declarative API, simple abstractions, and loose coupling. Make happy platform developers, in our opinion. check out Deus, GitHub Deus. You can search the GitHub issues for the V2 design document that talks about how we're decomposing the platform in V2. We should have an alpha hopefully by the end of the year, and then GA early next year. I also have stickers and shirts if you want to come by.
Cool.
Do you have anything about the Cloud Native Computing Foundation and any influence on this?
Yeah, so the Cloud Native Computing Foundation was the entity that was set up. It's independent from Google that they granted all of the Kubernetes code to. It is independent. It is moving forward. They're currently arguing about a lot of stuff. I wouldn't say that the Cloud Native Computing Foundation is necessarily dictating the direction of the project. It's just kind of like an IP holding company or whatever. So that people feel safe. We talk about lock-in, right? People feel safe going forward with Kubernetes.
Thank you. So what is your choice in terms of Docker container versus CoreOS? What's our Red Hat? Red Hat was okay.
So we run on top of CoreOS,
Oh,
which comes from our fleet days.
So what made you choose CoreOS?
Lightweight Linux distribution with all of the stuff that we needed baked in
I see.
is really what that was all about. All right, took 20 minutes, so.
Yeah, well, we probably did run out of time, but if there's anybody has any more questions, we can probably take one. I'm just kind of curious, when somebody wants to get started with AS, do you have like I don't know, click here and run it, but like, is there sort of a way you recommend folks get started?
Yeah, so if you go to deus.io, we've got installers for various configurations. You can run a local Vagrant install if your laptop is sufficiently beefy. We also have a bunch of CloudFormation templates. DigitalOcean, we're actually doing a big deploy day tomorrow. So if you want to get a couple of DigitalOcean nodes, you can get that up and running through Terraform. So it's relatively straightforward to get running.
Okay, great. Well, thank you very much, everyone. Okay, so next up, I don't have anybody specifically to come and speak about Docker, so we're going to skip that for now. We're going to come back to it later. But next up, we have the folks from OpenShift. I know Lear is here. There we go. There he is. Okay. And Gordon is right over here. So I think we kind of divided and conquered. Do you want to go ahead and give a? Why don't you go first?
Sure. Yeah, I'm going to probably be the higher level thing
Yeah.
here, so this will probably be a good.
And grab this slide shared.
Gordon left his MacBook sitting at home for this trip, so
Thankfully, we have the cloud.
thankfully we have the cloud. I ran out and bought a Chromebook yesterday, which are like $200 these days. It's really rather impressive.
Okay.
Thank you.
Speaking of that, just by way of, I don't even know what your name's title. What's your title?
Oh, I don't know. I go by Cloud Evangelist or Cloud Product Strategy or something random like that.
Strategy, definitely. Oh, it's automatically forwarded.
No idea.
Was this a PDF or was it a?
I think PDF.
Okay. If it decides to do the automatic thing,
Yeah, I guess go use single page, maybe. Yeah, single page. Go use.
all right.
Oh yeah, we're going to be happy.
All
Good.
right, so take it away. And just again, I've known Gordon actually for quite a while through most of the podcasts, but also just from your writings and stuff. So thank you for offering to do this, and like literally like the last minute.
Yeah, so this is a presentation carefully crafted over minutes. So yeah, I'm Gordon Half, and I'm an evangelist at Red Hat, which means I sort of cross-portfolio messaging and strategy and evangelism and all kinds of things. So including platform service, OpenShift, and just going back a few minutes here,
conference you're gonna make a speech?
SDI Summit
Okay,
is a new event. So, what's happening here? You know, I think we're seeing a change in sort of three areas. We're moving towards more agile development, and there's a couple of tracks here, a track here called DevOps Summit, and is kind of the next evolution of agile development. We're developing cloud apps, which are more modularized, loosely coupled set of applications, and we're running them on, call them open hybrid clouds, or whatever term you like to use. And the idea is there's a lot of open source here, whether or not the open source is exposed, as in the case of public clouds, and it's hybrid in the sense that we have both on-premise IT and public IT. So from a kind of a DevOps perspective, this is sort of what the workflow looks like. You're creating this, at least sort of looking forward with this containerized type of environment as opposed to more traditional virtualized environment. You then have this continuous integration, continuous development sort of workflows, and then you're deploying out the app using the type of scheduled and orchestrated workflows that you're kind of just hearing about, using things like Kubernetes, using things like Mesos. And then there's all these continuously iterative feedback loops. So once things are out in production, you're continuously monitoring, you're continuously updating, and so forth. So that's sort of your DevOps workflow. And then in terms of the applications themselves, the sort of extreme version of this will go by, often goes by microservices. This idea that will be very small units of function that are developed in many cases by a single team of people. One of the things that sometimes defines small is something one person can hold in their head. But whether you take that extreme version or not, you have these lighter weight APIs, lighter weight communication protocols. It's kind of different from the SOA 1.0. If I call it SOA 2.0, half of you will leave the room right now, and Dave will be unhappy with me. But I think we've got a better understanding of the functional separation of things. It's also much more open source and open standards oriented. SOA 1.0, I think cynical among us would say, was an opportunity for various large companies that we won't name to lock people in with their proprietary enterprise service buses and so forth. And in general, it's a more loosely coupled type of architecture, and that leads us to this kind of big shift in what the infrastructures look like. And we actually just heard, I think, a pretty good rundown of what this looks like. You're kind of evolving from this monolithic app container, scaled up by writing, Sun Microsystems or IBM or Hewlett-Packard a big check and buying a bigger server. I mean, that was traditionally how you scaled up. Now you go out and buy more x86 servers from, to exaggerate a little bit, whoever is offering you the best deal that month, and rack and stack, and you scale out using software, essentially, the availability using software. And the advantage here is it can be more robust. You have to build in the availability at the software level, but it can be more robust, and just faster iteration and release. And this is a kind of a different version of that same stack, but the same idea. And I think, too, kind of the key discussion point here, one of the things that we're seeing, one of the trends that we're seeing, and I always hate it when speakers say this because it's the fault of the speaker. I know this is a little bit hard to read, but the idea is that you're bundling, in this case, operating system, orchestration layer, the Docker container packaging, and that's really how we think about Docker. It's the packaging and portability mechanism essentially for containers. And we're we're bundling that into, in this case, from Red Hat, so like Red Hat Atomic Enterprise Platform, Core OS is a very popular other example of this. And then you move higher up the stack, and you have a platform as a service like OpenShift. And the way I look at platform as a service is it's taking some of these various higher levels of orchestration and scheduling, and also some of the user interface elements, like I say, okay, we're going to bundle all this stuff together. We're going to give you essentially an opinionated version of what you need to develop and deploy applications. And that's not going to be for everyone, but it simplifies things for those what makes sense for, and for others they can go to the lower level of abstraction, but then they have to do more work themselves. So essentially what you're doing is you're bundling together a lot of these tools. And these are tools for operations and infrastructure, though we're talking DevOps-y, and those boundaries get a little bit fuzzy. But the things that predominantly affect ops, this containerized infrastructure, the orchestration and scheduling stuff, some of the higher level governance, so, I can put this kind of workload in the public cloud, but this I will keep on premise. This data cannot go into a foreign country, that kind of thing. Config management is changing a bit as we look towards this, what's often called immutable infrastructure, this idea that you don't change things once they've been deployed. And there's the various automation, packaging, and sort of updating mechanisms. And then if you look at developers, and this is some of the more often called DevOps type of tools, things like collaboration tools, how do people communicate with each other, and like something in the software and service category, Slack is popular here, heck, IRC plays here, CI/CD, Jenkins is a really popular tool these days, various types of issue tracking, bug systems, source code controls, like GitHub, code review. And as I say, I think ultimately PaaS is mentioned here, and the reason this is from a study that IBC did for us back in, I think it was around June or so, sort of looking at DevOps early adopters and what was important to them, and 80% expected PaaS to play a critical role in their DevOps efforts. Now, mind you, these are early adopters, these are enterprise decision makers, so you kind of take that into account in interpreting these numbers. But basically, what they're saying, and Gartner has made similar recommendations, is, there's all this stuff you can do on your own, but typically you probably shouldn't. If you're not a web startup out in California with a really high developer expertise, maybe you should think, okay, integrated approach. And that's pretty much what we've done at Red Hat with OpenShift. It's pretty much the idea of Cloud Foundry is that you kind of have this lower level programmable infrastructure, and it could be bare metal. I show it as OpenStack here. I think that's one interesting question, is how things are going to play out over the next few years. Is are we going to decide that this virtualized infrastructure is unnecessary? It's an unnecessary level of abstraction. If any of you are here tomorrow, Brian Cantrell speaking in the DevOps track, and he's with Joyent, and he is very opinionated in this topic, as well as being a very knowledgeable and entertaining speaker, so you may want to check him out. And then on top of that, you're running this composed microservices in containers, and this is kind of where you have your Docker packaging, it's where you have Kubernetes, it's where you have Mesos, and again, this, as was mentioned in the previous talk, I think this, where the orchestration orchestration and scheduling, kind of where those separate is going to be an interesting area. There's a lot of things that are almost being relearned from grid computing in this space, which I find kind of amusing in a way. And then on top of that, you kind of have your hybrid policy-based management, you kind of have your content repository service catalog, all those kind of things. And one of the things that you're seeing happening, and actually we've been saying, we actually set up a whole new business unit at Red Hat relatively recently to do what is bringing a lot of these components together. And for those who choose to do so, I mean, it's all open source, but for those who choose to do so, offering a packaged product to say, here's everything together, and yeah, we're making some decisions for you, but it's going to be easier if you just sort of take the package. And again, I think that's one of the dynamics that's going to play out. So that is all I have, and any questions I can answer?
All right.
That's a lot of material, I know.
So how does Red Hat deal with it's called a technical fragmentation on container? There are lots of on PaaS platform, You
On
guys,
fragmentation?
You like
Well,
OpenShift versus Cloud Foundry and Bluemix, so many, right? I mean, HP handle.
Well,
And
a number of those things you mentioned are all based in Cloud Foundry. I mean, with OpenShift, one of the things we're doing differently is the whole thing is open source. So we have OpenShift origin. We do run an online service needs the on-ramp. I think one of the things is applications still, applications are still portable. I mean, the fragmentation would
OpenShift
probably
is
more
support
the
multi-cloud
operations.
like AWS, Azure, Google Compute.
So OpenShift can run wherever RHEL runs.
Yeah.
OpenShift is supported wherever RHEL is supported.
But
Red Hat
All
Enterprise
you
Linux.
need is, all you
Red
need.
Hat Enterprise Linux.
Yeah.
Okay.
Yeah.
Wherever Red Hat Enterprise Linux is supported,
Actually, yeah.
OpenShift is supported there.
Okay.
Yeah.
Alright? So basically, portability is like, you can take OpenShift and run it on this.
Yeah.
You can run it on a physical machine,
The
on a
family.
virtual machine,
Yeah,
on EC2, on OpenStack, wherever you want. You
yeah.
can install OpenShift.
I tend to agree with you, but there are a lot of tied up to JBoss, a lot of your own middleware.
We are not tied to our own middleware. We
Okay.
provide middleware out of the box if
Okay.
you want to use it.
Okay.
The reason being, let's say our middleware is all open source. JBoss middleware is all open source, right?
That's the
We don't have,
different.
let me answer the question completely because that's an allegation I hear, right?
Yeah.
This middleware that Red Hat supports is open source middleware,
Yes.
right? There is no licensing involved there.
Yes.
Whereas if you take other middleware coming from IBM or
Oracle,
WebLogic from Oracle, there is licensing involved.
Yeah.
We cannot support somebody else's middleware that is licensed because there are licensing implications, right?
Yeah.
So, for example, if you want to run some other middleware on the top of OpenShift, which is a PaaS, you create a Docker image for that, get it and run it, we'll run it.
It's like a
It runs.
plug-in, like a plug-in.
Exactly.
So okay, I totally agree with you on the PaaS side. Probably you guys need to do more marketing, than Cloud Foundry. But anyway, how was this container fragmentation?
No.
Hey,
Say it again. What is
we
it?
should probably,
Marketing
take
and
this
more
offline.
aggressive marketing than Cloud
Yeah.
Foundry.
And we're getting a little bit too specific.
Okay.
And we're also running out of time, so I want to make sure that Gear gets a chance to give his 5-minute talk.
Oh yeah. Okay.
And what I asked Gear to talk about was some of the choices they made in using, some of the choices they made when they put together.
I'll try to keep it short, 10 minutes, because
Yeah, keep it to 10 minutes.
some of the
talk.
concepts that
We still have one more talk after this.
Oh.
So we'll be done in about 20 minutes, folks. Is that working for you here?
the choices that are made in OpenShift or the concepts that are part of OpenShift are also already covered by JSON because the architecture is pretty much similar. Only the tools in each layer which Jason presented earlier are different in OpenShift, but more or less they are the same. So, and technically I think if you create a Docker image, if your application turns into a Docker image, that image, in my understanding, should run equally well on OpenShift, and you can take the same thing and run it on DICE as well. If things were done right, right? But from OpenShift's perspective, I'll answer the question. Let me complete this thought, right? From OpenShift's perspective, if you have a Docker image, you can get the Docker image and run it in OpenShift. So portability standpoint, the question that you were asking before, right? If you build an application and put it in a PaaS, would it be locked to a PaaS? The answer is no from OpenShift standpoint. And I think the answer would be the same from DICE.
At a PaaS layer, I agree, but the problem is, if like I was originally targeting for AWS API, so it will be harder for me to move away from AWS to Azure or any kind, because there's an API lock.
That is not PaaS, right? That is
yes, that's not
infrastructure as
PaaS, I
a
understand. Yeah.
So let's talk about the stack from OpenShift standpoint, right? The bottommost layer that you see there, I hope, is it clear enough? Okay. The bottommost layer that you see there is the container host, right? That is the host operating system that can run containers. About an year and a half back, beginning of 2014, Red Hat made a decision that we would support containers natively as part of operating system, right? And we decided on Docker being that approach. Oops. Perhaps I should also put power. This doesn't.
You might have to,
This came on.
you might have to rejigger it or something, take it out, turn it, rejigger? Not sure what the right word is. Is it jigger, is that the right word? Is it? I thought like, when you got the little TV cable where you're trying to like, do the antenna or something.
Okay. Direction problem. This cable is not long enough to turn on.
Okay.
So the container host, which is the host operating system, Red Hat made a decision about a year and a half back that we would support containers natively in our operating system. So RHEL 7, which is the current version of Red Hat Enterprise Linux, supports Docker containers natively. We went with Docker because Docker has become we made a prediction last year that Docker would become the de facto standard for containers in the industry. And that is true, that prediction came true, right? Everyone wants to use Docker. Containers have been there for quite some time, right? OpenShift itself as a platform as a service has been there for many years now. We were running our own technology for containers. We used to call them gears. And again, last year we made a choice that when we decided to move towards Docker, we also re-architected OpenShift to run with Docker as the containers. So everything that runs inside OpenShift, any workload that runs in OpenShift today with OpenShift version 3 runs as Docker containers, right? So the container API, the second layer, is Docker. So in case of OpenShift, the containers are not running as a separate layer on the top of operating system. They are running natively, right, as Docker containers. We don't take Docker and convert it to something else like another type of container and run it. We run it as Docker containers, right? So basically, if you create an application in OpenShift, it is a Docker image. It gets instantiated as Docker container. So ideally, once you create an application, from portability standpoint, you can take the same thing and run it without OpenShift on your machine as well, right? So from the standpoint of portability, don't worry about it. Now, the third layer is orchestration. For all the good reasons that Jason talked about, the same thing applied to OpenShift as well. We adopted Kubernetes right at the beginning of 2014 when Google came out with Kubernetes as an open source project, which has its roots from Borg, right? Where Google spins up 1 billion containers a week. That's their scale. And they started Kubernetes as an open source project based on their Borg. And when that was open sourced as Kubernetes project, Red Hat jumped onto the bandwagon. We are the highest committers to Kubernetes project after Google. And we made Kubernetes as our orchestration and management layer, right? Why? Take a Docker container, run it on your machine. It runs very well, right? Docker run command. Take a couple of Docker containers, run them on your machine. Yeah, they'll connect and they'll run. But take the same Docker containers and run it at web scale in your data center on a bunch of nodes, scale to thousands. What does it take, right? That's where the orchestration engine comes into play. So Kubernetes is the answer for that.
So,
Now,
sorry about
these-
that. Quick question.
yes, sir.
What is your take on those a lot of promising stuff they are offering, like it's called a stripped down OS kernel, Linux kernel, like
Yes.
a core OS, there are quite a few,
Yes.
Kubernetes and Linux networks.
So, I should have talked about that at the container host level. So, the operating system is RHEL is what I said, right? RHEL has two flavors now. One is the complete RHEL that supports containers, which is RHEL 7.
Yeah.
Another flavor of RHEL, which we are calling RHEL Atomic, is the stripped down version of RHEL.
Oh, yeah.
The size of that is 1/10 of the size of the actual RHEL, right? It has only those things that are needed to run containers. It is RHEL, but it has only those features that are needed for containers. You don't have any other unnecessary libraries. So the size of that RHEL Atomic is like 1/10, and OpenShift runs on RHEL Atomic as well. So in that other example that Jason was talking about, the place where they are using Core OS, which has only those features to run containers, the supported version of that, Core OS is still open source, right? But the supported version of something like that from Red Hat is RHEL Atomic. Now the entire stack that you are seeing here is all supported. It was released, it was GA'd in June of this year, and it is right now supported by Red Hat. Now, so that answers your question, right? About the
Yeah,
stripped
so
down
which
system.
means, according to my understanding, which means those startups do not have too much room to get a chance to win.
Sorry, say that again?
Because you are also offering those kind of stripped down OS kernel, that's not rocket science, so I mean, the chance for them to succeed is slim.
Chance for whom to succeed?
For those startups offering those kind of stripped down Linux kernel, is
For
very
the
low.
startups. See,
Yeah.
this is all open source, right?
Yeah, yeah.
There is nothing that is preventing those startups from taking open source and creating their own operating system if they want to, right?
Yes.
What did Oracle do with RHEL? They took RHEL and they call it Oracle Linux by just rebranding it, right? If Oracle can do it, why not a startup?
Yeah,
Anyone can do
There's
that.
reason. Okay, I see. I get your point.
What makes the difference is how do you support? What kind of infrastructure is there? How much experience is there for the company that supports it?
If they build a successful ecosystem like Docker, they'll be formidable.
Exactly, right.
Other than that,
It's an open market, it's open source, right? So now these three things will, when you put together, it looks like those are sufficient to create what we call a platform as a service, right? And even this morning I heard people who were part of this session in the morning, I presented the same thing in the morning in a more detailed window. There are some organizations who have taken these technologies and created their own paths. And I keep meeting customers who did that. And they have been working in the same kind of timeline than where we started. They began their journey last year, and now they have a fairly good path. But it is limited to those 3 layers, nothing above that. What is above that? Now you need those, in order to run your applications as Docker containers, right? Let's say you are creating a Java app. What do you need to run your Java app? The middleware? If you are creating a PHP application, you need middleware for PHP. You want to run database, MySQL. You need middleware for MySQL. Where are they coming from? They have to be Docker images. Now, go and search for that Tomcat on Docker Hub. How many will you find? Hundreds? Which one will you trust? Which one doesn't have security holes? How do you know that, right? That's where Red Hat again comes in, again with the support model. We provide certified Docker images for a bunch of open source technologies. Again, I'll qualify because you're asking a question that you are trying to lock us into Red Hat specific products. No, these are not Red Hat specific products. PHP, Python, Ruby, Perl, Node.js, all the open source technologies, we have Docker images, right? And these are certified Docker images and they are supported by Red Hat. In the sense there is, if let's say there is a security vulnerability, we fix that and we'll make it available to you immediately. Right? That's the advantage Red Hat provides. Now for Tomcat and JBoss, right, we provide middleware in those areas as well. Like the supported versions of Tomcat is called JBoss EWS, Enterprise Web Server. The supported version of Wildfly is JBoss EAP, Application Server. The supported version of our integration products are Fuse, AMQ, BPM, PRMS. We are providing those Docker images if you want to use them, right? If not, you want to create your own Docker images for the technologies of your choice, you are free to do that. Create those, expose that into OpenShift using that layer. All you have to do is create a Docker image, make it available for everyone in your organization to use. That's it. It's your self-certified Docker image. And if you want to create self-certified Docker image, we provide container development kit as well. You create your own Docker images and you support it yourself. Right? That's that next layer. Now on the top of all this, one of the things that Jason was talking about, source to image process, right? As a developer, I don't want to learn another new technology to deploy my applications. I'm happy with my Java, I'm happy with my PHP, I'm happy with my Node.js. I don't want to learn more, right? Why should I learn Docker again? Hey, operations guys, you deal with it. Or operations might say, I don't want to deal with it, let it come out of the box, right? That's where source to image process comes in. In this case, we take the source code and all the developer has to do is say, my source code is in this Git repository, it is lying here, here is the URL. Hey OpenShift, take this URL, create an application for me. OpenShift will pull the source code, it takes the Docker image for the technology of your choice, let's say the source code is that of PHP. It pulls the source code from Git repository. It goes and pulls the PHP Docker image. It takes your source code, layers that on the top of this Docker image, the technology Docker image, packages the entire thing, makes it your application specific Docker image now, right? Earlier it was just Docker image for PHP. Now when you put your application layer on the top of it, it becomes very specific to your application, right? It's an application Docker image. Now that Docker image, it pushes that into a registry that we deploy in OpenShift. So you'll get your own Docker hub for your organization within OpenShift, right? And any application Docker image that you create will get pushed into that registry. And then OpenShift goes and deploys that as well. from development standpoint, all you're doing is saying, here is my source code, build an application for me. The rest of the things, OpenShift will take care of it. That entire DevOps cycle is built into OpenShift. Right? Now let's say I want to make a code change. Just first time deployment is not enough, right? I want to make a code change. So you make a code change. As usual, you do a commit to the Git repository. Using webhooks, OpenShift can listen to the commit from the Git repository, do a rebuild, create a new Docker image, push it again into the registry, and then redeploy it. If you have 100 instances of your application running, it will do a rolling deployment, right? It will create a new instance of app with a newer version, remove the old instance. Stand up another new instance, remove the old instance. Don't want to do it instance by instance? You can provide, let's say, I want to do 10% at a time, 25% at a time. Let's say you have 100 containers, 10 instances will be removed and 10 new instances will come. That's rolling deployment. Let's say you don't want to use rolling deployment because the kind of change you are making doesn't support rolling deployments. Let's say. You want to bring down and bring up the new version. All you need to do is go and change the configuration to say, don't use rolling, use recreate. That's it. Everything is configurable. All the things that Jason explained before, because these concepts are built into Kubernetes. Most of them were, lot of these concepts were contributed by the folks from Red Hat. The ability to select the nodes on which the applications to be deployed. How your scheduler within Kubernetes will deploy applications. Where does it go? Where to spin up those application instances? Kubernetes calls them pods. So where do the pods get spin up? All these decisions are based on policies. You decide how you want them to run. Yes, sir.
What is your default container repository? Is it a Docker one or a Red Hat one or your suggestion or recommendation is a
It is a Docker registry, yes.
Okay, so your default is Docker registry.
Yeah, it is a Docker registry. The Docker registry gets installed along with OpenShift.
A lot of users, they prefer their own.
Sorry?
They prefer their own registry. They don't want to